Hi there and welcome to CodeFramer. So in this video, we will be understanding about dependency inversion principle, which is the last and the final design principle in this particular tutorial. So in the last few videos, I have explained about the first 4 design principles, which were single responsibility principle. Then I explained about open close principle, then Liskov substitution principle. And then in the last video, I explained about interface segregation principle. So I hope that you have understood all those design principles well. So if you are new to this channel and also if you are watching this video for the first time, then you can continue to watch this particular video because this particular design principle is independent of all other design principles that we have discussed till now. But I highly recommend you to just go back and see all those videos as well so that you get good understanding about all the design principles that are available. So having said that, let us begin. So first of all, let us just recall what is dependency inversion principle or what this particular design principle states. So it basically states that one should depend upon abstraction and not concretion. So if you have good understanding about object-oriented programming, then you must be aware about the abstract methods and also the concrete methods. So what this design principle is saying is that you should depend upon the abstraction and not the concretion. So we will see in the example what it really means. And also it states that high-level modules should not depend upon the low-level modules, which means that all the low-level implementations that you have done in your application should be in such a way that the high-level implementations that you have done should not depend on it. So I know that it will be little vague to understand from the definition about this particular design principle. So now let us directly jump into the example and try to understand what this design principle basically means. So as part of the example, we will create an application where we will store information about different people, or you can say different individuals, and we will also store the relationship between these individuals that we are going to store. And later you should be able to basically browse any relationship of a particular individual with other individuals. So we will create that kind of an application and we can name this particular application as relationship browser. So in order to create this particular application, let us first create a class which will basically store all the relations of different people, right? So we can first import the enum module. So we can write from enum import enum, and now we can create a class called relationship which will basically store all the relations. Say for example, someone is a parent of someone or someone is a child of someone. So let us say that initially we just have these two relationships. So our application will basically support only these two relationships. I mean, we can have different relationships, right? We can store sibling relation or any other relation, but initially our application will store only the information about parent and child relationships, right? So we can create a class and we can name this particular class as relationship. So we can write relationship and we can inherit enum. Now inside this class we will store all the relations. So as I said that we have parent and child relations, so we can write parent and also we can have child. So these are the two relations using which we will create relationships between different individuals, right? So which means that we have to basically store those individuals, right? So we need to create a separate class in order to create those individuals. So let us name this class as person, and inside this class we can create our constructor. So we can write def and then init, and inside this constructor we will have name as the input parameter of the person, and then we can simply store that into self.name. So self.name is equal to name. So this is our person class using which we can create person objects, which means that each and every individual will be a unique person object. So till now we have created two classes. One class, which is the relationship class, will have the information about the relations that are available in this particular application, and the second class is the person class where we can basically store each and every individuals as a person object. So now let us implement the low level module. So remember that now we are going to implement the low level module, and I want you to remember that this particular class that we are going to create is a low level module, because then only you will be able to understand the definition of this particular design principle, which is that the high level module should not depend upon the low level module, right? So now let us implement the low level module where we will create a list, and inside that list we will store the information about different individuals and also their relationships with each other. So as you could see here that we are trying to implement something which seems like a low level implementation, right? Because when it comes to low level implementations, this is what you do. You basically store the data into your database, or you create certain data types where you can store some data, or you can process some data, and also you can process the input that you're receiving from the user. So these are low level implementations, right? And that is exactly what we are going to do in this particular class. So since we are going to store the relationships between different individuals, let us name this class as relationships, and now we can define the constructor of this class. So we can write def init, and here we can declare an empty list. So we can name this variable as self.relations, and we can declare this as an empty list. So which means that we will use this particular list to store the information about different individuals and their relationship with each other. So in order to store the relationships between different individuals with each other, there has to be a method using which we can basically take information about different individuals and also set the relationship between these individuals, right? So we need to create a separate method for that. So in order to create that method, let us write def, and then we can name this method as add parent and child, because remember that our application initially supports only two relationships, which is parent and child, and this particular method will take parent and the child as the input. Now once this method has received the parent and the child, all it has to do is simply append those information inside this self.relations list. So we can write self.relations and then append the parent. So we can append this information as a tuple. So we can write parent and then we can declare the relationship between the parent and the child. So of course, since the first input is the parent, which means that the first individual is the parent of the second individual, which is passed to this particular method. So we can use the parent relation from the relationship class, and finally we can mention the child. So in this tuple, as you can see, that the first person object, which is the parent, and the second person object, which is the child, is now having a relationship, and that is basically stored inside this particular relations list in a tuple. And in this tuple, the first element is the parent, the second element is the relationship between these two individuals, and the third element is the child. And similarly, we can create one more tuple where basically we can add the reverse relationship, right? So for the child, parent is the parent relation, right? So we can write self.relations.append, and inside this we can mention the child as the first element, then we can write the relationship as child, and then finally we can mention the parent, which means that for this child, this is the parent and the relationship between them is child. So basically we have just reversed this particular tuple. So here we have completed our low level implementation. So as you can see here that we are creating a list in our low level implementation where we are going to store the relationships between two individuals, and also we have created a method using which the user can add different individuals along with their relationships. So this is our low level implementation. So now let us write a class for our high level implementation. So as part of our high level implementation, we can basically do research on the kind of data that we have stored. So in our data, we have information about different individuals and also the relationship between those individuals, right? So that kind of information we have in our memory right now. And this particular application is about browsing relationships of different individual with other individual, right? So which means that we can create a separate class where we can basically do research of different individuals in order to find the relationship that they have with other individuals. So we can write a class called research, and inside this particular class we can declare our constructor method, and this constructor method will basically take relationships as the input object. So the object which is coming out of this particular class will be the input for this research class, because if you remember that this is where we are storing all the relations between each individual, right? So we will need the object of this particular class so that we can loop through each and every relationships and find information about a particular individual, and that is exactly what we are trying to do in the research class, right? So that is why we have imported the relationships object inside the constructor. So here we can simply write relations, and we can simply take this particular list into this variable. So we can write relationships dot relations. So we are basically storing the relations list from this particular object inside this particular variable, and now we can loop through this variable relations and check the information about a specific individual. So we can write for r in relations. Remember that this relations list is having list of tuples, right? And each tuple is having three elements, where the first element is the name of the first individual, the second element is the relationship between the two individuals, and the third element is the second individual, right? So like that we have stored our information. So we are looping through all the tuples inside this particular relations list. So let's say, for example, in our application, we are trying to find the children of an individual called John. So in order to do that, we can write if r index of 0, because remember the first element in the tuple is the first individual. So if r index value of 0 is equal to John and the second element of the tuple is equal to the relationship parent, then in that case simply return John has a child with name, and then you can call the third element inside the tuple, right? So you can write r of 2 dot name. So this will be the output. If we have stored an information about John into our memory along with its children, then we should be able to see this output in our console, right? So now since we have written our low level module and also the high level module, let us see how this is working. So just remember here that in our low level module we have created a list where we can store the information about different individuals individuals along with the relationships that they have with other individuals. And in our high level module, we are basically doing the research, or we are basically trying to find information about a specific individual with other individuals, right? So this is your low level implementation, and also this is your high level implementation. So now let us create some person objects. So let us say we create a person who will be a parent. So we can write parent equals, and then we can write person class, and let us name this particular person as John. Then we can create child 1. Again, we can call the person class, and here we can name this person as Mike, and we have child 2, which will have a name as, say for example, Rick. So now we have created all the person objects, so which means that now we can create an object with the relationships class, so that we are able to access this particular method add parent and child, using which we are able to relate these three person objects with each other, right? So we can instantiate the relationships class by writing relationships, and then we can call relationships class, and now we can just access the add parent and child method, and inside that we can pass parent as the first person object and then the child 1 as the second person object, and similarly we can just write child 2 and add child 2 as well as the child of this particular parent. So now we have basically related all the person object with each other, so which means that we are ready to do the research on these individuals using our research class. So which means that we can simply write research, and inside that we can simply pass the relationships object, because remember that this particular research class takes the relationships object and then it basically scans through each and every relations that are stored in the relationships object, and then it tries to find the relationship that John is having with other individuals, right? So now if we execute this code, then as you can see that we are getting the desired result. So it says that John has a child with name Mike and John has a child with name Rick. So our code is basically working fine. There is no issue at all in this particular application. If you think about it, logically it is working fine, but we are in a serious trouble in this particular application because we have completely breached the dependency inversion principle. And now let us try to understand how we have basically breached this particular design principle. So if you remember, our design principle states that your high level module should not depend upon the low level module implementation, right? But in this case, the research class is our high level module, right? So we can just write high level module for this class, and we can write this class as low level module. Now you must be wondering that how these two modules are related with each other. The reason why they are strongly coupled with each other is because you are basically trying to find the relationship of different individuals, assuming that your information is stored in a list. So in your high level module, if you notice here, you are basically trying to find the information about this individual, assuming that your information is stored inside a list, right? And that is why you are using these indexes here while trying to search for the name John and also the relationship between John and other individuals. And this is a serious problem. And this is you are doing because you have declared this relations as a list in your low level module. And this is why your high level module is completely dependent upon your low level module. Because now say for example, in future, if you want to store your information about different relations inside a database, or if you want to store inside a dictionary. Now if you come to this particular low level implementation and you modify this particular data type in your low level implementation, that will have direct implication on your high level module, right? It will immediately break your high level module. So which means that any changes that you are making in the low level module will have direct impact on your high level module. And this is the reason why your high level module is completely or strongly coupled with your low level module here. And this is something that we would not want, because any changes in your low level module will have impact on your high level module, and it will mean that your users who are basically using your code will have an application which is unreliable, right? Because every time you make any changes in the low level module, the code which is written in the high level module will instantly break. And this is exactly the situation that we need to avoid by following the dependency inversion principle. So I hope that now you understand that how basically the high level module can be strongly coupled with the low level module and what kind of problems or challenges it can bring in the future. So now since we have understood how we can breach dependency inversion principle and what really happens when we breach dependency inversion principle, now let us see how basically we can solve this problem. So now in order to solve this problem, let us just recall the definition of dependency inversion principle. So what was the definition? It said that one should depend upon abstraction and not the concretion, right? So which means that we need to basically move this search functionality in our low level module, and somehow we can create a separate abstract interface using which our high level module can do the search using our low level module implementation. So now let us create the interface. So we can come here and we can write a class called relationship browser, because remember that is the functionality of this particular application, right? So it can store different individuals along with the relationships, and also later you can browse the relationship of a particular individual with another individual. So that is the basic usage of this particular application, right? So we can write class relationship browser, and inside this class we can simply declare an abstract method. So we can write abstract method, and then we can write def find children of, or you can say find all children of, and we can pass the name of the person for which we are trying to find all the children. And then you can simply write pass, because this is just an abstract method which we are going to use in our low level module and also high level module in order to do the search. So now you have created this particular abstract class. So what you can do is you can import this abstract class into your low level module. So you can just write relationship browser, and now since you have imported this particular abstract class into your low level module, now you can do the search operation inside this low level module. Because remember that in this low level module you have declared the kind of data type using which you are going to store all the information, right? It could be a list, it could be a dictionary, or it could even be a database. So it is up to you the way you want to store your data. But that design of storing the data is basically implemented inside your low level module. So which means that the search operation that we are going to do in any individual should be inside the low level module. So now in order to implement this find all children method, you can write def find all children of, and you can take name as the input parameter to this method. So now you can loop through all the relations one by one. So you can create a for loop. So you can write for r in self.relations. So you can write if r of 0 is equal to the name and r of 1 is equal to relationship dot parent, then you can simply yield the child, which is stored as the third element in the tuple. So you can write r of 2. So this is the implementation of this particular method find all children of inside a low level module. So as you can see here that now we are doing the search of any individual inside our low level module and not the high level module, which means that now we can decouple the high level module from the low level module, right? So in future if you want to make any changes inside your low level module in terms of changing the way you want to store the data or any other change, then you will have to make the changes related to the search also in your low level module. So which means that you will have complete control over the functionality of your application, and the high level module will not have any dependency on the low level module. So now let us make the necessary changes into our high level module in order to completely decouple the high level from the low level module. So in the high level module, this was the code which was basically coupling both the high level module and the low level module together, right? So we can simply comment this part of the code now. So I'm just having this code just for your reference, because this code will be available in the GitHub in my GitHub account, and I will share my GitHub accounts link in the description of this video. So you can go to my GitHub account and download all this code for your reference. So now we can write our constructor method once again. So we can write def and then init, and this constructor will take the browser object, which is nothing but our relationships object. And remember that in this relationships class, we are basically inheriting our interface, which is nothing but our abstract class, relationship browser. So we will take the object of our relationship class as an input to this particular research class, because remember that we are storing all our information about relationship of different individuals in this particular relations list, which is inside this relationships class, right? So we can have the access of this particular list only if we have the access of the object which is created from the relationships class, right? And that is why basically we are taking the browser object as the input to this particular class, which is nothing but the relationships object. So now once you have taken this browser object as the input to this class, we can create a for loop using which we can loop through all the relationships that are available in this particular relationships object. So we can write for p in browser dot find all children of, and then we can pass John, right? Because we want to fetch all the children of an individual called John, for which we have created a person object here, right? So for this particular individual, we want to find all the children's, and then we can print the same f string, which was John has a child with name, and then we can call the p object itself. Because remember that this particular method find all children of is basically returning the name of the child, right? Or the name of the second individual, which is nothing but the third element in your tuple, right? So you can simply write p here because it is basically returning the third element in your tuple. So you can simply write p here. So I hope you understand why we have only mentioned p here. So now we have created our high level implementation as well. So as you can see now that your high level implementation has no dependency at all with your low level implementation, because in your low level you are basically controlling the way you are trying to store the data and also the kind of data that you want to store. So which means that you are basically storing information information about different individuals along with the relationships inside a tuple, and you are storing those informations inside a list, which means you have a list of tuples. And also you have implemented the entire search functionality inside your low level module itself, which means that in future if you want to make any changes inside your low level module, you can control all the functionalities of your application within that low level module itself, so that your high level module is not impacted because of any change that you are making inside your low level module. So this is the main benefit of following this particular design principle. So now after having implemented both our high level module and the low level module by following the dependency inversion principle, now let us execute this particular code and see what is the result that we are getting. Oh, okay, we are not getting any output, so which means that we have some bug inside. Okay, so here I have missed to add the name variable, so we can just mention name here. So now I think everything seems to be fine. So now let us try to execute this once again. Yeah, now we are getting the output. So as you can see here that we are getting the same output now, but yes, this time we have followed the dependency inversion principle, which means that our high level module is completely independent of the low level module. So any change that you make in the future in the low level module will have no impact on your high level module. And this is exactly what this particular design principle states. So I hope that now you are able to understand what is dependency inversion principle and also what will really happen if you breach this particular principle. Now whenever you are creating any particular application, then always be a little cautious about this particular principle, because usually this will skip your mind when you are coding, right? Because this is a very tricky principle to follow, because always you have to keep this in mind that your high level implementations that you are doing, which means that any part of your code which will be accessed by others in order to access your low level implementations in your application, those high level modules or classes should not depend upon your low level modules. So you need to find a way where your high level modules are always independent of the changes that you are making in the low level module. But if you follow this particular design principle, then you will have a very stable application, and whenever you are making any modifications in your low level module, it will have no impact on the high level implementations that you have. Because once your application has grown larger, and if it is scattering a lot of traffic, and also if you have large amount of code in your system, then it will be really difficult to make any changes in your low level modules if required, if they are tightly coupled with the high level implementations. So you can understand the kind of complexity or problems that you will end up in if you do not follow this particular design principle. So I hope that this video was helpful for you to understand this particular design principle, and if you have any doubts or queries related to this design principle or any other design principle that I have taken before, you can definitely post those queries and questions in the comment section. I will definitely respond to you. And also if you have any thoughts or suggestions for the future videos, then also do post those feedbacks into the comment section. So having said that, I hope you enjoyed this video and also you were able to get a lot of value from this video. So from the next video, we will finally start understanding all the design patterns. So first we will start with the creational patterns, where we will start with the builder. So if you like this video, then hit that like button, share it with other code lovers, and also subscribe to Code Framer for more videos in the future. Thank you and see you next time.